Far below the last silver shimmer of moonlight, beneath the waves that rise and fall like breathing glass, the ocean becomes a different planet. A small beam from a submersible cuts through the darkness, and for a moment, the black water fills with drifting particles, like snow falling upward in a world without sky. Beyond the glass, there is no horizon, no wind, no familiar shape to guide the human eye, only pressure, cold, silence, and the possibility that something ancient-looking is moving just outside the light. The bottom of the ocean is not one place. It is a chain of hidden worlds, dim twilight zones where animals glow like distant stars, vast abyssal plains where food arrives as slow rain from above, volcanic vents where life gathers around heat and chemistry, and trenches so deep that mountains could vanish inside them. To a human body, these places are almost impossible. The pressure can crush ordinary machines. The cold steals energy. The darkness removes the sense we trust most. Yet, life is there, patient and strange, shaped by rules that have almost nothing to do with our own. Every creature here is an answer to a problem we can barely imagine: how to find food, avoid danger, reproduce, and endure in a place that gives almost nothing freely. Science has reached this world through deep-diving vessels, remotely operated vehicles, sonar maps, cameras, samples, and decades of ocean research. We know that the deep sea is home to microbes, crustaceans, fish, worms, jellyfish, mollusks, echinoderms, and communities built around fallen carcasses or mineral-rich vents. We also know that much of it remains poorly explored, not because it is empty, but because it is remote, dark, and difficult to study, far beyond ordinary human reach. So the question is not simply what lives at the bottom of the ocean. The deeper question is how anything lives there at all. How does life survive without sunlight? What happens when food is rare? When every movement costs energy, when a flash of light can become a signal, a disguise, or a trap? And what does this hidden world do to us when we finally enter it inside a fragile metal sphere, realizing that our own planet still contains places where humans are only visitors? Tonight, we will descend slowly, layer by layer, from the last blue light into the black water below. We will follow the rain of the dead, drift across the abyssal plains, approach the living cities around hydrothermal vents, and look down into the trenches where pressure becomes a landscape of its own. If you enjoy quiet journeys through Earth's most mysterious places, you can like this video, subscribe to the channel, and leave a comment telling us where in the world you are watching from tonight. Now, let the room grow darker. Lower the light, breathe slowly, and allow the surface world to fade behind you. The ocean is waiting below, silent, immense, and alive. The beam of light slides downward, and the ocean answers by becoming quieter. Above, the surface is still somewhere behind us, lifting and folding beneath the moon, but its presence fades with every meter. The water that once held reflections now holds only color, then less color, then almost none. Blue is the last memory of the sky. It lingers like a soft veil around the submersible, pale and familiar at first, then darker, colder, heavier, until even that blue begins to feel like something borrowed from another world. At these upper depths, the ocean is still close enough to human understanding. Sunlight enters the water and breaks apart. Red disappears quickly, then orange, then yellow, leaving the shorter blue wavelengths to travel farther than the rest. This is why the shallow sea can look peaceful and bright, even when it is already hiding a vertical world beneath it. Near the surface, life is busy because light is energy. Microscopic algae, drifting plants, and photosynthetic plankton use the sun to build the foundation of marine food webs. Small animals feed on them. Larger animals follow. Fish gather in schools that turn like silver smoke. Turtles move with old patience. Dolphins cross the light. Sharks patrol with a confidence that feels ancient. To the human eye, this is the ocean we know, because it is the ocean that still welcomes sight. But even here, there is a warning. A swimmer at the surface can look down and see only a few meters below. A diver can descend through blue water and feel the daylight weakening around the body. The human mind begins to measure safety by distance from air. Every instinct understands that there is a line somewhere below, invisible but real, where a return becomes difficult. We are mammals of breath and warmth, built for land, built for gravity that pulls us against solid ground, built for horizons. The sea has no ground for a long time. It has no walls, no paths, no doorways, no branches to hold. Its openness can feel gentle from above, but once you begin to sink into it, that same openness becomes a kind of enclosure. The first change is not darkness, it is scale. The ocean is not deep in the way a lake is deep, or a valley is deep, or a canyon is deep. It is layered in distances that the body cannot picture all at once. 100 meters is already more than most humans will ever enter without serious training. 200 meters is deeper than sunlight can comfortably rule. 1,000 meters is a descent into a pressure and darkness beyond ordinary experience. Several thousand meters is no longer a place for a diver. It is a place for steel, titanium, ceramics, cables, instruments, and machines built with extreme care, because any mistake is multiplied by the weight of water. From inside a submersible, the descent feels strangely calm. There is no falling sensation like dropping through air. The vehicle sinks through a thick medium, held and slowed by the very water that threatens it. Outside the porthole, tiny organisms drift past like sparks that have forgotten how to burn. The sound is not the roaring ocean of storms and beaches. It is mechanical and close. Fans, pumps, the faint vibration of motors, the small clicks and creaks of a sealed craft adjusting to pressure. For the people inside, the most important landscape is not only outside the window, it is also the hull around them, the oxygen monitor, the communication line, the depth reading, the awareness that the human body has become a passenger inside a temporary artificial shell. The last bright creatures of the surface do not vanish all at once. They thin out. A few fish cross the light. A jellyfish opens and closes like a slow, living umbrella. The water becomes spacious, and the sun above shrinks into a pale memory. This is the beginning of the twilight zone, the mesopelagic realm, where daylight still arrives, but is too weak for photosynthesis to support the world as it does above. It is a region of half-seen shapes and long migrations, one of the largest habitats on Earth, yet almost entirely hidden from daily human life. Each evening, countless small animals rise toward the surface to feed under cover of night. Each morning, they sink back down to escape the predators that hunt by sight. This daily vertical migration may be the largest movement of animal biomass on the planet, happening silently under ships, under storms, under cities of light along distant coasts. For a human observer, the twilight zone is unsettling because it is neither bright nor fully dark. It is a borderland.
The eye wants objects to declare themselves, but here they withhold their outlines. A fish appears as a glimmer, then turns and becomes invisible. A squid hovers for a moment, its body almost transparent, then contracts and is gone. The water seems empty until the light catches something close, and then the emptiness is suddenly crowded. This is where the old fear of the unseen begins to wake. On land, darkness usually covers a surface. There is a floor beneath your feet, a ceiling above, walls or trees or stars to orient you. In the water column, darkness surrounds you in every direction. It is not in front of you, it is around you, above you, below you, and behind you. The animals here have evolved around that uncertainty. Many are small, because small bodies need less food. Some have large eyes to capture the last traces of light descending from above. Others have bodies that are silvery, transparent, dark red, or black, each strategy shaped by the problem of being seen. A transparent animal can nearly disappear in the dim blue, its tissues allowing light to pass through. A dark animal can merge with the water below. A silvery animal can reflect the faint brightness around it, hiding its outline. These are not decorations. They are survival, written into skin. In a world where hunger is common and encounters may be rare, every advantage matters. Then, the first living lights begin to appear. At first, they are easy to mistake for reflections from the submersible, tiny
Points shimmering in the water, but they blink, move, and vanish with intention. Bioluminescence is one of the deep ocean's most extraordinary languages. Many animals in the darker ocean can produce light through chemical reactions inside their bodies or with the help of symbiotic bacteria. To us, light means discovery. It means a lamp in a room, a lighthouse on a coast, a signal of safety. Down here, light is more complicated. It can be a lure. It can be camouflage. It can be a warning. It can be a way to recognize a mate in a vast darkness where two members of the same species might otherwise pass without knowing. A lanternfish carries light organs along its body, like tiny stars arranged in patterns. Some squid release glowing clouds to confuse predators. Certain deep-sea fish use lights beneath their bodies to match the faint glow from above, making themselves harder to see from below. This is called counter-illumination, and it is a quiet masterpiece of disguise. To a predator looking upward, the prey's silhouette might otherwise appear against the last dim brightness of the surface. By glowing just enough, the animal erases its own shadow. It becomes part of the water. For the human mind, this is one of the first true reversals of the descent, the thing we reach for in fear, the thing we switch on when we need certainty, becomes, in this world, a possible deception. A diver follows light. A fish may die by doing the same. The soft green dot ahead might be a promise, or it might be a mouth waiting in stillness. This does not make the deep sea cruel. It makes it efficient. Energy is precious here. Food is not evenly spread. If a creature can make another creature come closer, rather than spend energy chasing it, that creature has found a way to survive in a place where waste is dangerous. As the descent continues, color thins until the submersible's lights become the main source of vision. Without them, the outside world would be nearly black to human eyes. The depth gauge changes steadily. Numbers replace landmarks. The body cannot feel the full pressure outside because the pressure stays beyond the hull, but the mind keeps translating it into weight. At 100 meters, pressure is already far greater than at the surface. At 1,000 meters,
It is immense. Every square centimeter outside the craft is being pressed by a column of seawater rising toward the world above. The ocean is not just around the submersible, it is leaning on it. Pressure is the invisible monster of the deep sea. It has no shape, no teeth, no sound of its own, but it defines everything. A hollow object that is not built to resist it can collapse. Gas spaces compress. Materials bend, crack, or fail if engineers misjudge the forces involved. Human beings, who carry air-filled lungs and soft tissues adapted to surface conditions, cannot simply enter this realm. Even scuba divers are limited by pressure, gases, decompression, temperature, and the need to return safely. The deeper ocean belongs to vehicles and remotely operated machines, because the human body is not designed to negotiate with thousands of meters of water. Yet, the animals outside are not being crushed. That fact can feel almost impossible at first. The reason is that many deep-sea creatures do not contain large compressible air spaces like the lungs of a surface mammal. Their bodies are mostly water, and water does not compress easily. Their proteins, cell membranes, and biological systems are adapted to function under pressure that would be deadly or destructive to organisms from above. Some deep animals brought to the surface are damaged or distorted by the change, just as we would be destroyed by going down unprotected. This is important to understand. The deep sea is not a nightmare for the creatures that belong to it. It is home. Still, for us, the thought is enough to awaken something old. The fear is not only of being eaten, it is of being placed somewhere our body has no answer. On land, danger can often be met with movement. We run, hide, climb, call out, make fire, gather with others. In the deep ocean, most human instincts have nowhere to go. There is no running from pressure. There is no shouting through kilometers of water in the ordinary human sense. There is no building a fire. There is no climbing to air unless the machine works. Survival becomes quiet, technical, and dependent on systems too complex to be felt by the skin. The submersible sinks below the
twilight into the midnight zone, the bathypelagic realm where sunlight no longer reaches in any meaningful way. Here, the ocean becomes less like a dim room and more like space filled with water. Temperatures fall toward near freezing in many regions. The surface weather no longer matters in any direct, visible way. Storms may rage far above, but down here, there is no rain, no breaking wave, no flash of lightning across clouds. The world is stable, cold, dark, and vast. Its stillness is not emptiness, it is time slowed down. In this darkness, some animals become more dreamlike, and others more severe. A viperfish may carry long, needle-like teeth that look too large for its head. A fangtooth, despite its fearsome appearance, is a small animal compared with the monsters of imagination, but its proportions seem almost designed to disturb a surface creature's sense of normality. Anglerfish use lures that glow near their mouths, turning patience into a hunting strategy. Gulper eels have enormous mouths and expandable stomachs, adaptations useful when meals are rare and unpredictable. These forms can look exaggerated, but each one is a practical response to scarcity. Food is the central question. In the sunlit ocean, energy begins with light. In much of the deep sea, energy arrives indirectly from above. Bits of dead plankton, fecal pellets, mucus, fragments of animals, and other organic material drift down through the water as marine snow.
Most of it is consumed or decomposed before reaching the bottom, but some continues downward, feeding creatures in the dark. Larger events can matter greatly. A dead fish, a squid, or eventually the body of a whale can become a sudden feast in a place where calories are widely scattered. Much of deep-sea life is shaped by the ability to wait, to notice, to conserve, and to take advantage when chance arrives. The viewer inside the submersible would not see this as a simple diagram. It would appear as small motions at the edge of light, a pale shrimp flicking away, a soft-bodied animal turning slowly, a fish hanging almost motionless as if suspended by thought. The deep ocean teaches a different rhythm. Surface animals often seem busy because the surface is rich in energy. Down here, movement can be expensive. Waiting is not laziness, it is survival. A creature that moves too much may burn what it cannot easily replace. A hunter that misses too often may weaken. A prey animal that reveals itself may not get a second chance. This is why the deep can feel haunted, not because it is filled with ghosts, but because so much of its life is quiet. The animals do not need to announce themselves. They do not need to fill the space with constant motion. A mouth can wait in darkness. A lure can pulse once. Then again, a transparent body can drift like a piece of water that learned to breathe. The human imagination, trained by forests and cities and open fields, tries to complete the unseen shapes. It adds monsters where there may be only animals, but the emotional truth remains. The unknown feels alive before it is identified. The submersible's lights create a small theater in the black. Everything inside the beam becomes visible, and everything outside it becomes more mysterious by contrast. This is another deep-sea reversal. Light does not conquer the darkness. It sharpens the border between what is known and what is not. If the pilot turns the lamps slightly, the whole visible world changes. A patch of water becomes a cliff face. A shadow becomes a fish. A drifting thread becomes the tentacle of a siphonophore, part of a colonial animal that can stretch through the water in delicate, dangerous beauty. The deep ocean is full of forms that challenge the neat categories of surface thinking. Siphonophores are especially strange to human intuition. They are not single animals in the ordinary sense, yet they behave as a single drifting organism made of specialized units. Some parts capture prey, some digest, some help movement. The famous Portuguese man-o'-war lives at the surface, but many siphonophores live deeper, where their long feeding structures can hang in the water like invisible curtains. For a small animal, crossing such a structure can be fatal. For a human viewer, it is a reminder that life in the ocean does not always choose the shapes we expect. It can be modular, translucent, extended, and almost architectural. The further down we go, the more our own senses become unreliable guides.
The human eye wants sharp edges, but the deep offers translucence. The human ear expects sound to arrive in familiar ways, but underwater sound travels differently, and the submersible isolates the people inside from much of the outside acoustic world. The human skin expects to read air temperature, wind, and touch, but here the body sits in a controlled cabin, separated from the true environment by a barrier it must trust completely. Exploration becomes strangely indirect. We see through glass and cameras. We touch with robotic arms. We sample with containers. We know the deep sea by instruments before we know it by feeling. This distance can make the experience more eerie, not less. A person in a forest can break a twig, smell soil, feel cold air, hear insects,
and sense the slope underfoot. A person in the deep ocean sits inside a machine, while the machine interprets the world. The hands do not touch the water. The lungs do not breathe the environment. The ears hear pumps. The eyes look through a circle of thick glass. The outside is close enough to see, but impossibly far away in every practical sense. A fish may pass within a few meters, yet it belongs to a pressure, temperature, and darkness that the human body can never share. At times, the descent passes through clouds of life so small they seem like dust. At other times, there is nothing visible at all. This alternation is part of the deep ocean's power. It refuses to perform constantly for the observer. It exists on its own terms. The submersible may travel for long stretches through apparent emptiness, and then suddenly encounter a glowing animal, a swarm of crustaceans, or the pale shape of a squid. That unpredictability creates a quiet tension. Every second of darkness might remain darkness, or it might open. The creatures that appear do not always match our expectations of size. Popular imagination often turns the deep into a realm of giants, and some large animals do hunt in deep waters, including sperm whales and large squid. But much of deep-sea life is small. Tiny crustaceans, small fish, gelatinous animals, worms, microbes, and delicate drifters dominate many encounters. This is not disappointing. It is more truthful, and in some ways, more unsettling. The deep is not only frightening because of enormous, unseen bodies. It is frightening because life can persist almost everywhere, in small, patient forms, in darkness too complete for us to enter unaided. Gelatinous animals are among the most beautiful and least familiar inhabitants of the open ocean. Jellies, comb jellies, salps, larvaceans, and other soft-bodied drifters can be damaged easily by nets, which means older methods of sampling often missed or destroyed them. Cameras and gentle collection tools have revealed how common and important these fragile creatures can be. Some pulse with rows of shimmering cilia that scatter light into rainbow-like bands. Others trail fine feeding structures through the water. In the blackness, their bodies seem made from the idea of water itself, as if the ocean had briefly organized its own transparency into life. For humans, soft-bodied life changes the emotional texture of the descent. Not everything strange is threatening. Some things are so delicate, they feel almost impossible. A jellyfish drifting past the window does not inspire the same fear as an anglerfish, yet it deepens the mystery. It shows that the deep is not simply a horror landscape. It is a place of elegant solutions, of bodies that survive by yielding rather than resisting, by drifting rather than chasing, by becoming almost invisible in a world where visibility can be dangerous. Still, the fear remains, because beauty here does not make the environment safe. The submersible continues downward, and the pressure continues to rise. Each layer of water above adds to the weight. The people inside may speak softly, if they speak at all, because the mind naturally lowers its voice in a vast, dark place. There is a strange intimacy to deep-sea exploration. A few humans in a small cabin, surrounded by a world larger than continents, watching creatures that may never have encountered a human-made light before. The scale makes thought quiet. The midnight zone is not the bottom. It is a passage. Below it lies the abyssopelagic realm, over much of the ocean, where depths can reach several thousand meters, and the seafloor finally begins to become a destination rather than an idea. But before the bottom
appears The descent passes through a long darkness that teaches patience. The viewer may imagine that after the surface disappears, the next important moment is the sea floor. In reality, the water column itself is a habitat, immense and layered, with communities living at different depths, responding to temperature, pressure, oxygen, food, and the faint rhythms of day and night far above. Those rhythms still matter, even where sunlight cannot be seen. The daily migration from the twilight zone connects surface productivity to deeper waters. Sinking particles carry carbon downward. Predators follow prey. The ocean is vertical, and life uses that verticality. For human beings, who mostly live across horizontal landscapes, this is difficult to feel. We think of places as maps spread flat beneath us. The ocean asks us to think in depth. A location is not only latitude and longitude, it is also a pressure, a temperature, a light level, a distance from food, a distance from air. The submersible lights catch another animal, perhaps a small anglerfish suspended motionless, its lure hanging forward like a thought. The thinness image of the anglerfish is often distorted by scale. Many species are not large, and some males in certain groups are tiny compared with females, with unusual reproductive adaptations that can involve permanent attachment. The details vary among species, and the deep sea still contains many mysteries, but the broad lesson is clear. In a place where finding a mate may be difficult across vast darkness, evolution can produce strategies that seem extraordinary to surface minds. Scarcity shapes not only feeding, but reproduction itself. A few meters away, the light may reveal nothing at all. That nothing is also part of the story. The deep ocean is not packed like a coral reef. It is spread out, and its distances matter. A predator cannot assume prey will appear. A mate cannot assume another of its kind is nearby. A scavenger cannot assume a meal will fall soon. The bodies, behaviors, and senses of these animals are built around probabilities that humans rarely experience. Our world is crowded with signals, voices, signs, roads, smells of food, screens, buildings, other people. Theirs is sparse. To live there is to endure long intervals between opportunities. This endurance is one reason deep-sea animals often seem alien. They reflect a world that does not reward haste. Some may grow slowly, live long, mature late, or invest energy carefully, though patterns differ across species and habitats. In the cold and dark, metabolism can be low, especially where food is limited. But the deep sea is not uniform. Near vents, seeps, and carcasses, life can become dense and active. In the open water and on broad plains, it may be scattered and slow. The ocean bottom is not a single ecosystem. It is a mosaic of conditions, and the descent is only beginning to reveal that complexity. The human impact of this realization is subtle, but deep. At first, the viewer may ask what creatures live below, because strange animals are exciting. But gradually, the question widens. What kind of planet contains a world like this, hidden under the familiar surface? What does it mean that most humans will never see the largest living space on Earth with their own eyes? We often speak of exploration as if the unknown is far away, in space, across other worlds. Yet here, on our own planet, beneath waves crossed by ships and satellites, there are regions that remain difficult, expensive, and dangerous to visit. The submersible continues. The temperature outside is close to the cold of deep water, though exact conditions vary by region. The cabin stays controlled, a pocket of warmth carried through an environment where human warmth would vanish quickly without protection. This contrast gives the journey its emotional center.
Inside, breath, skin, voices, instruments, electricity, memory of land. Outside, pressure, darkness, cold, and animals that do not know the names we give them. The boundary between the two is a wall, a window, a technology, and a question. How thin can safety feel and still be real? Now, the bottom begins to announce itself before it appears. The water may show more suspended material. Instruments may indicate distance. The pilot may slow the descent. The lights tilt downward, no longer searching only open water, but expecting a surface. For a long time, there is nothing beneath them but black. Then, gradually, something pale
enters the edge of the beam. Not a cliff, not a monster, not a city, but sediment. The seafloor arrives quietly. After kilometers of descent, the largest boundary in the ocean appears as a soft, almost blank plain. This first sight can be surprising. After so much darkness, the bottom may look calm, a muted landscape of fine particles, small tracks, low ripples, scattered rocks, perhaps the slow movement of an animal crossing the sediment. There is no dramatic gate, no sudden wall declaring the end of the descent. The ocean floor simply emerges, patient and unlit, as if it had been waiting without waiting. For the human viewer, the feeling can be more powerful than spectacle. This is the place that receives what falls from above. This is where the long rain of organic matter settles. This is where bodies, dust, shells, and time gather. But the journey to the bottom has already changed the meaning of the question. What lives here cannot be understood only by naming species. The descent has shown the conditions that make those species possible. Light fades and life learns to glow, hide, or stop needing sight in the same way. Food becomes rare, and life learns patience, opportunism, expansion, and economy. Pressure increases, and life builds itself without the fragile airspaces that make our bodies vulnerable. Cold slows the pace, and life adjusts its chemistry and behavior. Darkness removes the horizon, and life communicates through signals too soft for us to notice without machines. The seafloor is not the end of fear. It is where a different fear begins. In the open water, the danger was that something might emerge from any direction. At the bottom, the danger feels older and quieter. The landscape itself seems to erase human importance. A footprint from a machine may remain in soft sediment. A small animal may cross it later, unaware of the meaning humans attach to arrival. The ocean does not become more human because we have reached it. If anything, reaching it makes clear how much of Earth is not arranged around us. A sea cucumber may move slowly through the light, feeding on organic material in the sediment. A brittle star may lift delicate arms. Small crustaceans may scatter. A fish may rest close to the bottom, conserving energy. None of this looks like the dramatic monsters of old maps. Yet it is more astonishing because it is real. These creatures live under pressures that would destroy us, in darkness that would blind our instincts, in a cold silence far removed from sunrise. They are not visitors. They are citizens of the deep. The human beings inside the submersible are the temporary ones. Their time is limited by oxygen, power, mission plans, and the need to return. They cannot stay as the animals stay. They cannot step outside and walk across the plain. They cannot build a fire, pitch a tent, or drink from a stream. They can observe, record, sample, and wonder. This limitation gives the deep sea its dignity. It resists being turned into ordinary scenery. It remains a place where the human role is small, careful, and brief. As the submersible moves just above the bottom, its thrusters stir faint clouds of sediment. The pilot must be cautious. Disturbing the sea floor can obscure the view and affect the fragile environment immediately around the craft. Robotic arms may extend with slow precision. Cameras pan across tracks and small animals. Each movement is deliberate because haste belongs to the surface. Down here, even exploration must learn the rhythm of the deep. The darkness beyond the lamps remains complete. The visible world is now a circle traveling across the ocean floor. Within that circle, details sharpen: grains, shells, burrows, the faint marks of animals, the soft geometry of a landscape built particle by particle over long periods. Outside the circle, the abyss continues. This is the emotional shape of human knowledge itself, a small light moving through a vast unknown, revealing enough to understand more than before, never enough to end the mystery. The first minutes above the sea floor also reveal how misleading the word bottom can be. It sounds final, as if the ocean were a container with a floor that simply waits beneath everything else. But the deep sea floor is active in ways that are often slow, hidden, or too large to notice from a single window. Sediment is constantly being shaped by currents, burrowing animals, falling particles, and the chemistry of the water above it. A plain that looks still may be crossed by faint flows. A surface that looks empty may contain communities living within the mud itself. Microbes work there in numbers beyond easy imagination, breaking down organic matter, transforming chemicals, and helping connect the living ocean to the buried record below. To humans, mud is often ordinary. It belongs to riverbanks, boots, construction sites, rainy fields, but abyssal sediment is not ordinary mud in a human sense. It is a slow archive of the planet. It can contain mineral grains, remains of microscopic shells, volcanic dust, and particles that have traveled down from the surface over long periods of time. Layer by layer, the seafloor collects traces of climate, life, erosion, eruptions, and death. A scientist looking at a core of deep-sea sediment is not simply looking at dirt. They are reading a quiet history written in particles, a history that settled through darkness long before any human machine arrived to disturb it. The animals that move across this surface are part of that same slow story. A sea cucumber processing sediment is not only feeding, it is turning the sea floor over, changing the texture of the habitat for smaller organisms. Worms and burrowers create passages that allow water and chemicals to move through the mud. Tiny crustaceans search for fragments of food. Brittle stars and other echinoderms extend arms into the water or across the bottom, collecting what the current brings. None of this is dramatic in the way surface life often appears dramatic, but it is continuous. The abyss lives by small actions repeated over immense spaces. For a person watching through the glass, this can create a strange emotional shift. The fear of the descent begins as fear of what might suddenly appear. Then
Near the bottom, it becomes something quieter, the recognition that life does not need our pace, our light, or our attention. It can continue without spectacle. It can survive in darkness so complete that a human imagination tries to fill it with monsters, while the real animals go on feeding, hiding, sensing, and waiting. The deep sea does not become less mysterious when it becomes more understandable. It becomes more mysterious because understanding reveals how much is happening beyond the reach of ordinary perception. The submersible's presence is temporary, almost fragile in this context. Its lights may startle animals that normally experience only bioluminescent flashes or darkness. Its thrusters may lift sediment that has rested quietly. Its cameras may record a creature never seen alive before by human eyes. Yet that creature has its own life, its own pressures, its own place in a network that existed before the lens arrived. Exploration, at its best, is not a conquest of this world. It is a brief conversation with it, conducted through light, patience, and respect. It reminds us that discovery can be gentle, and that wonder sometimes arrives not as shock, but as stillness below. And somewhere beyond this first plane, the deep ocean becomes stranger again. Not all bottoms are flat and quiet. There are canyons cut into continental margins, seamounts rising from darkness, cold seeps where chemicals seep from the seafloor, hydrothermal vents where hot, mineral-rich fluids pour into freezing water, and trenches that drop still deeper into the hadal world. The descent through darkness has brought us to the floor, but the floor is not a single answer. It is the beginning of many answers. For now, the submersible hovers in its small pool of light. Above it lies the long column of black water, the twilight zone, the last blue, the waves, the air, the moonlit surface. Around it lies the abyssal seafloor, quiet and alive. The human body, protected but humbled, has crossed from the familiar ocean into the hidden one. The question of what lives at the bottom is no longer a curiosity from above. It is now a presence outside the glass, moving slowly through sediment, waiting in darkness, glowing at the edge of vision, and feeding on the faint rain that falls from a world it will never see. The faint rain continues to fall through the beam, each particle small enough to seem weightless, yet important enough to help sustain an entire hidden world. From above, it is only debris, fragments of plankton, tiny shells, bits of waste, the remains of animals that lived their brief lives in brighter water. Down here, it becomes weather. It drifts through the darkness in slow
curtains, touching the seafloor so gently that the impact is almost impossible to imagine. There are no fields here, no forests, no sunlight pressing energy into leaves. There is only this silent descent of matter, the long afterlife of the surface. To a human watching from the submersible, marine snow can look peaceful, almost beautiful. It softens the blackness. It gives the light something to hold. But it also reveals a truth about the deep ocean that is more severe. Life at the bottom often depends on what the upper ocean can spare. The creatures below live beneath a world of abundance they cannot visit, waiting for traces of it to fall. Some particles are eaten while still drifting. Others reach the sediment, where bacteria, worms, crustaceans, and many small animals begin the patient work of using what remains. Nothing is wasted easily in a place where energy arrives slowly. The seafloor beneath the lights may appear still, but it is being searched constantly.
Small animals move through the sediment, over it and within it, reading the bottom with senses that do not resemble our own. An amphipod may find a fragment of food before the camera notices it. A sea cucumber may process the mud grain by grain, drawing nourishment from organic material mixed into the sediment. A brittle star may extend its arms and gather particles carried by faint currents. These animals do not need drama to make the abyss alive. Their lives are built from repetition, precision, and endurance. In the darkness beyond the immediate glow, other scavengers wait for larger accidents. The deep sea is a place where a single falling body can become an event. Most days may bring only a sparse rain of particles, but sometimes something far greater descends. A fish, a squid, a shark, or, in rare and powerful cases, the body of a whale. When a whale dies and sinks, it can carry an enormous store of energy to the deep seafloor. Scientists call this a whale fall, and it can transform a patch of abyssal plain into a temporary oasis, attracting waves of scavengers, worms, microbes, and specialized communities over time. The image is strangely solemn. A whale that once breathed air, sang through the water, and rose to the surface beneath open sky, eventually comes to rest in total darkness. Around it, animals gather. Hagfish, sleeper sharks in some regions, amphipods, crabs, and other scavengers may feed on the soft tissue. Later, bone-eating worms and microbes help use what remains. The carcass changes from body to habitat, from animal to island. To us, death often feels like disappearance. In the deep ocean, death can become geography. It can create shelter, chemistry, food, and a center of life in a place where centers are rare. For the people inside the submersible, a whale fall would feel like finding a village in the night. The surrounding plain might be sparse, quiet, and wide. Then, suddenly, there would be movement everywhere. Pale animals gathered near bones, small bodies clustering and scattering, traces of feeding, competition, and transformation. The sight would not be violent in a simple way, but it would be honest. The deep ocean does not soften the fact that life feeds on life. It reveals it slowly, without spectacle, as part of a cycle that reaches from sunlight to darkness and back through the chemistry of the sea. This is one answer to what lives at the bottom of the ocean. Animals that know how to wait for the dead. That may sound grim from the surface, but in the abyss, it is a form of balance. The deep sea receives the remains of the upper world and returns them to circulation. Microbes break down organic matter. Scavengers carry energy into their own bodies. Predators may follow scavengers. The seafloor is not a graveyard in the ordinary sense. It is a slow engine of recycling, a place where falling life becomes living life again. As the submersible glides onward, the plane gives way to subtle variation. The camera may pass over tracks in the sediment, small mounds, burrows, trails, and delicate marks made by animals moving in darkness. These traces matter because they show behavior even when the animals themselves are absent. A track is a sentence left in mud. It says that something crossed here, fed here, turned here, searched here. For scientists, such marks can reveal activity that a brief visit might otherwise miss. The abyss may look empty during a single pass of the lights, but the sediment remembers movement. Some of the most important life here is also the least visible. Microbes live in the sediment, in the water, on rocks, on animals, and around chemical sources.
They are not background details. They drive transformations that larger creatures depend on. They break down organic matter, mediate chemical reactions, and form the base of some deep ecosystems. Human eyes naturally search for animals with faces, fins, shells, or limbs, but much of the deep ocean's power belongs to life too small to feel cinematic at first glance. Without microbes, the grander images of the deep would lose their foundation. This microbial world changes the emotional scale of the descent. A giant squid or a glowing fish may capture fear quickly, but microbes introduce a quieter awe. They suggest that life does not require grandeur to be profound. It can exist as a film on rock, a community in sediment, an invisible metabolism turning one substance into another. In the deepest places, where the human imagination expects emptiness, there may be biochemical activity written at scales smaller than sight. The abyss is not only populated by strange animals, it is also inhabited by processes, by transformations, by life doing work in silence. The submersible rises slightly from the bottom and enters the water just above it, where animals move between the seafloor and the dark column above. Here, the boundary between bottom life and deep water life becomes blurred. Some fish hover close to the sediment. Some crustaceans swim briefly and settle again. Some animals use the bottom as a surface, others as a refuge, others as a feeding ground. The phrase "bottom of the ocean" can make the place sound flat and simple, but the real environment is layered, even at the floor. A few centimeters above the sediment can be different from a few meters above it, and both are different from the mud below. One pale fish appears in the light, its body soft-looking and spare, moving with little urgency. Deep-sea fishes often seem slow when viewed from submersibles, but that slowness can be misleading. Some are conserving energy, some may be startled by the lights, some are adapted to an environment where sudden bursts matter more than constant speed. In the deep, survival may depend on doing very little until the exact moment action is required. A still body is not necessarily weak. It may be economical. It may be waiting for the rare instant when movement is worth its cost. The anglerfish remains one of the most powerful symbols of this strategy, though the group is diverse and not all species look like the familiar nightmare image. In the deep sea, some anglerfish use a modified fin ray as a lure, sometimes associated with light produced by bacteria. The lure draws prey toward the mouth, allowing the predator to hunt by attraction rather than pursuit. The horror of the image, for human viewers, comes from its intimacy. A small light in darkness feels like comfort. A mouth hidden behind it feels like betrayal. But the animal is not deceiving in a human moral sense. It is solving the problem of hunger in darkness. Another fish may carry teeth so large they prevent the mouth from closing in the way we expect. A viper fish, for example, has long, fang-like teeth and a hinged skull adapted for capturing prey. The fang tooth, with its oversized teeth and compressed body, looks fierce when magnified by cameras, though it is much smaller than its appearance suggests. These animals are often presented as monsters because their faces disturb our surface expectations. But deep-sea predators do not need to be large to seem alarming. In a world where food is rare, the ability to seize and hold a passing meal can matter more than elegance. The mouth becomes a central theme in many deep-sea adaptations. A large mouth increases the range of prey that can be swallowed. An expandable stomach allows an animal to take advantage of meals that may not come again soon. Sharp teeth can prevent escape.
These features look extreme because the environment is extreme. For humans, whose food systems are built around storage, choice, and regularity, it is difficult to feel what scarcity means at biological depth. Many deep-sea animals live in a world where opportunity arrives unpredictably, and evolution favors bodies prepared for that uncertainty. Yet, not all hunters in the deep rely on grotesque jaws or glowing lures. Some predators are swift, soft, and intelligent in ways that feel closer to a different kind of
Fear. Squid and other cephalopods move through deeper waters with bodies that can change color, shape, and posture. Some are small and delicate. Others, such as the giant squid, have become part of human legend because they inhabit depths we long struggled to observe directly. The giant squid is real, not a sailor's invention, but much about its life remains difficult to study. Its rarity at the surface, its deep habitat, and its elusive nature allowed imagination to grow around it for centuries. The fear of the giant squid is partly a fear of scale, a body long enough to exceed a person many times over, arms and tentacles equipped with suckers, an eye among the largest in the animal kingdom. These details feel designed to wake the old human fear of being grabbed from the dark. The eye may be the most unsettling feature. Teeth and claws are frightening because they imply injury, but an enormous eye implies awareness. It suggests that something from the dark can look back. Even if that thought is more emotional than scientific, it is powerful. Humans are deeply sensitive to being watched. In reality, giant squid are animals adapted to deep ocean life, not demons waiting for ships. They are prey as well as predators, famously associated with sperm whales, whose stomach contents and skin scars helped confirm encounters long before living giant squid were filmed in their natural habitat. Their lives likely include hunting fish and other squid, avoiding larger predators, growing, reproducing, and dying within a vast environment where humans rarely intrude. The legend is larger than the animal, but the animal is extraordinary enough without exaggeration. It proves that large, complex creatures can move through depths that once belonged mostly to rumor. Then there is the colossal squid, a different species associated with cold southern ocean waters, with a heavy body and rotating hooks on some arm and tentacle clubs. It is not simply a larger version of the giant squid, and its biology is still known from limited encounters, including specimens brought from deep waters. These large cephalopods remind us that the deep ocean is not one uniform place. It has regions, temperatures, food webs, and histories. The animals of the Southern Ocean are shaped by different conditions than those in tropical depths. The bottom and the deep are not a single kingdom, but a network of worlds connected by darkness. For a human descending in a submersible, the idea of such animals nearby changes the feeling of the water. Even when none appear, the imagination makes space for them. A long shadow becomes meaningful. A movement outside the lamp becomes a question. This is not irrational. It is part of how human perception evolved. In darkness, assuming that a shape might matter can be safer than ignoring it. The deep ocean activates this ancient caution. It surrounds the observer with uncertainty, and uncertainty invites the mind to prepare for presence. Among the few mammals that truly enter the deep as hunters, the sperm whale stands apart. It breathes air, gives birth to live young, nurses its calves, and belongs to the same broad mammalian inheritance as humans. Yet it can dive far below the surface in search of prey, especially squid. Its body is built for these journeys in ways ours is not. It stores oxygen, manages pressure, and uses powerful sound to navigate and hunt in darkness. The sperm whale shows that a mammal can remain tied to air and still become a visitor to the deep, not inside a machine, but through its own biology. The contrast is humbling. A human needs a submersible, pressure-resistant materials, navigation systems, oxygen management, lights, cameras, and support crews to spend a short time where a sperm whale dives as part of its life. The whale rises to breathe at the surface, then turns downward into black water, carrying its own warmth and air within it. Its clicks travel through the ocean, creating an acoustic sense of space where sunlight is gone. To imagine that journey is to imagine a form of confidence humans do not possess in water. The whale does not conquer the deep. It belongs to a relationship with it, ancient and practiced. Sound matters deeply in the ocean. Water carries sound efficiently, and many marine animals depend on it for communication, navigation, or hunting. In the dark, sound can reach where light cannot. For sperm whales, echolocation clicks help reveal prey and surroundings. For humans inside a submersible, sound is filtered through technology and hull, but the idea of an acoustic world outside remains powerful. The deep is not silent in an absolute sense. It is silent to us because we are not equipped to listen properly. There may be currents, animals, geological activity, distant calls, and the mechanical sounds of our own machines. The silence we feel is partly our own exclusion. This exclusion shapes the emotional experience of exploration. We often imagine that seeing a place means knowing it. The deep sea resists that assumption. Cameras show forms, but not every chemical signal. Lights reveal bodies, but they can change behavior. Instruments measure pressure and temperature, but they do not recreate what it feels like for an animal whose entire body is adapted to those values. Human knowledge grows through careful observation, but it remains translated. The deep ocean is always being converted into something we can perceive: images, graphs, samples, sonar returns, maps. The real place remains larger than the translation. As the submersible continues across the sea floor, the scene may shift from scattered animals to a concentration of life around a particular source of energy. Before hydrothermal vents were discovered, many scientists assumed that the deep sea floor was mostly dependent on organic matter descending from the sunlit surface. Marine snow is still essential across enormous areas, but vents revealed another possibility. In certain places, seawater seeps into the crust, is heated by underlying magma, reacts with rocks, and emerges rich in minerals and chemicals. When that hot fluid meets cold, deep ocean water, it can form dark or pale plumes and mineral chimneys. Around these vents, life can gather in startling density. The discovery of hydrothermal vent ecosystems in the late 20th century changed the way scientists thought about life in the deep sea.
Here were communities not based directly on photosynthesis, but on chemosynthesis, where microbes use chemical energy to produce organic matter. These microbes can support animals such as tube worms, mussels, clams, shrimp, crabs, and other organisms, depending on the region and conditions. The scene is one of the most alien on Earth. Black water, high pressure, mineral structures, shimmering heat, and living bodies clustered around chemistry rising from the planet itself. To approach a vent field in a submersible would be to see the darkness become architectural. At first, there might be only rougher terrain, scattered rocks, changes in temperature or chemistry detected by instruments. Then the lights might catch a chimney, rising from the seafloor like a tower built by minerals. From it, fluid pours upward, sometimes dark with suspended particles, sometimes shimmering as it mixes with cold seawater. Around it, animals crowd in ways that contrast sharply with the sparse abyssal plain. The feeling is not like finding a monster, it is like finding a city where no city should be. The animals at vents are not there because the water is comfortable in any human sense. Vent fluids can be extremely hot, chemically rich, and variable, while the surrounding deep water is cold and pressurized. The community survives by occupying gradients, using the boundaries where chemistry, temperature, and oxygen create usable conditions. Giant tube worms, where present, do not feed with a mouth like ordinary animals. They rely on symbiotic bacteria housed inside their bodies, bacteria that use chemicals such as hydrogen sulfide as part of chemosynthetic processes. The worm provides access to chemicals and oxygen. The bacteria provide organic nutrition. It is a partnership shaped by an environment where sunlight is absent. This relationship is one of the clearest reminders that life is not always organized around the categories we find intuitive. A tube worm may look like a simple red plume rising from a white tube, but its survival depends on an internal microbial community and the chemistry of the vent. Mussels and clams at some vents and seeps may also rely on symbiotic microbes. Shrimp may graze on microbial films or participate in vent food webs in various ways, depending on species and location. The deep sea is full of such alliances. To ask what lives there is also to ask how organisms live together, how bodies become habitats for microbes, and how chemistry becomes flesh. For humans, vent ecosystems carry a special emotional charge because they seem to
loosen the grip of the sun. On the surface, nearly every meal is tied directly or indirectly to photosynthesis, to light caught by plants, algae, or cyanobacteria. Even meat, even grain, even fruit, even the oxygen we breathe, all point back to the solar-powered biosphere. At vents, life shows another pathway. It does not mean sunlight is irrelevant to the whole ocean, and many vent animals still rely on oxygen produced by photosynthetic life far above. But the local production of food through chemical energy expands the imagination. It suggests that life can gather wherever energy, chemistry, and stability overlap. This is why hydrothermal vents matter beyond the ocean. They influence how scientists think about life's origins and the possibility of life elsewhere. Some hypotheses about the origin of life involve chemical gradients and mineral surfaces in ancient ocean environments, though the full question remains unresolved. Vents also encourage interest in worlds beyond Earth, such as icy moons that may have subsurface oceans. Because if life can use chemical energy in Earth's dark ocean, it is reasonable for scientists to investigate whether similar energy sources could support life elsewhere.
This is not proof of alien life. It is a scientifically meaningful possibility shaped by what Earth's deep ocean has already taught us. The human feeling near a vent field is different from the feeling on the open abyssal plain. The plain humbles through emptiness and scale. The vent humbles through unexpected abundance. Around the chimney, animals may cluster so thickly that the seafloor seems to bloom without sunlight. White tubes, pale shells, moving crustaceans, microbial mats, shimmering water, and mineral towers form a landscape that looks less like the bottom of an ocean and more like a border between biology and geology. The planet itself seems to be feeding the living world directly, exhaling chemistry from its interior. Yet, vent communities are also temporary on geological timescales. Hydrothermal activity can shift, weaken, or stop as the seafloor changes. A thriving community may depend on a flow that will not last forever. When a vent dies, the animals tied closely to it may vanish from that spot, while new vents elsewhere may be colonized. This creates a different relationship with stability. The abyssal plain may change slowly, receiving its rain from above over long periods. Vents can be intense, localized, and impermanent. Life there must find, colonize, and persist around islands of energy in a vast, dark ocean. The search for these islands requires technology. Humans map the seafloor, detect chemical signals in the water, use temperature anomalies, and deploy remotely operated vehicles and submersibles to observe and sample. Each discovery depends on instruments extending human senses. We cannot smell the chemicals from inside the craft. We cannot feel the heat except through sensors. We cannot wander until we stumble upon a vent. We infer, follow clues, and then the lights reveal the result. This makes deep-sea exploration feel almost detective-like, but in a planetary way. The ocean leaves traces, and researchers learn to read them. Away from vents, other chemically rich habitats exist, including cold seeps, where fluids such as methane or sulfide can emerge from the seafloor at much lower temperatures than hydrothermal vents. These places can also support communities based on chemosynthetic microbes, including mussels, clams, tube worms, and other animals, depending on the seep. Cold seeps show that the deep sea floor contains multiple ways for chemistry to become life. Not all abundance comes from hot volcanic systems. Some comes from slower leakage, from sediments and geological processes that release energy-rich compounds into the water. The existence of vents and seeps complicates the simple image of the deep as a desert fed only by falling debris. Much of the seafloor is indeed sparse, but scattered across it are oases, carcasses, seeps, vents, seamounts, canyons, and other features that concentrate life. To understand what lives at the bottom, we have to understand this patchiness. The deep ocean is not evenly alive. It is alive in gradients, pulses, islands, and hidden networks. Some animals roam or drift between opportunities. Others are tied closely to a particular chemical source. Still others live buried in sediment, almost invisible unless scientists look carefully. The submersible leaves.
The vent field slowly, and the abundance fades back into darkness. This transition can feel like leaving a settlement and entering open country at night. The lights no longer catch dense clusters of animals. The bottom becomes quieter again. But after seeing the vents, the emptiness no longer feels empty in the same way. Now, every dark ridge might hide chemistry. Every distant rise might be a seamount with its own community. Every patch of sediment might contain microbial life and small animals beyond easy view. Knowledge changes the darkness. It does not remove mystery, but it gives mystery structure. Seamounts, underwater mountains rising from the seafloor, add another dimension to deep ocean life. They can alter currents, concentrate nutrients, and provide hard surfaces where animals such as corals, sponges, and other organisms may attach, depending on depth and region. Deep-sea corals do not need sunlight like tropical reef-building corals with photosynthetic symbionts. Many capture food particles from the water. Some grow slowly and can form important habitats for other species. To human eyes, a deep coral garden can be astonishing. Pale branches, orange or red forms under artificial light, fish moving between structures, life gathered on a mountain, hidden under kilometers of water. These habitats are beautiful, but also vulnerable. Slow growth can mean slow recovery when damaged. Bottom trawling, resource extraction, and other human activities can disturb deep communities before they are well understood. This brings the human story closer again. The deep ocean once felt unreachable enough to be safe from us, but that is no longer true. Fishing gear, plastics, chemical pollutants, noise, and exploration for minerals can extend human influence into places most people will never see. The creatures at the bottom may live beyond sunlight, but not beyond consequence. The thought is uncomfortable because it removes the illusion of distance. A plastic fragment dropped or lost at the surface can travel into deep water. Persistent pollutants can move through food webs. Carbon dioxide released into the atmosphere affects ocean chemistry and climate systems. Human sound can travel through the sea. The surface world does not stay at the surface. It sinks, spreads, dissolves, echoes, and settles. The deep ocean receives more than marine snow. It receives traces of human civilization, sometimes as faint particles, sometimes as visible debris, sometimes as changes too broad to be seen from a single window. For the viewer drifting through this dark landscape, the impact on humans becomes more than fear. It becomes responsibility. The deep ocean changes us by showing that there is no simple outside. We are connected to places we cannot visit. Our lives in cities, farms, ports, factories, and homes can touch animals that live under pressure and darkness. This does not require panic to be meaningful. It requires attention, a calm recognition that the planet is continuous, that the surface and the abyss are parts of the same system, and that ignorance does not create separation. Still, the deep is not only a place made fragile by human action, it is also a place that expands the human mind. Every expedition returns with images that seem to enlarge Earth. A transparent animal drifting in black water, a fish resting on a plain below any natural light, a vent chimney surrounded by life, a whale skeleton transformed into habitat, a microbe using chemistry in darkness. These discoveries do not make the world smaller by explaining it. They make it larger by showing that reality is more inventive than imagination. The emotional path of the journey is beginning to deepen. At first, the question sounded like curiosity. What lives at the bottom? Then it became environmental. How does anything survive here? Now, it becomes almost philosophical. What does it mean for humans that such a world exists beneath us? We are used to thinking of Earth as familiar because we can map it, photograph it, name it, and cross it. But the deep ocean reminds us that familiarity can be superficial. A planet can be home and still contain realms where we are biologically unsuited,
technologically dependent and mentally transformed by every meter of descent. This transformation is quiet enough for sleep, but strong enough to stay with the listener. The darkness outside the submersible is not an enemy. The animals are not villains. The pressure is not malicious.
The deep simply follows rules older than human comfort. That may be what makes it so powerful. It is not trying to frighten us, yet it awakens fear. It is not trying to amaze us, yet it does. It is not trying to hide, yet it remains hidden because reaching it is so difficult. The deep ocean has no need to perform mystery. It is mystery by condition. Ahead, the seafloor begins to change again. The plane slopes downward, almost imperceptibly at first. Instruments suggest a broader structure, a descent beyond the already deep world we have crossed. The submersible lights travel over sediment, then rock, then shadows that do not belong to small ripples or low mounds. Somewhere beyond the beam, the ocean floor breaks into deeper forms, trenches, escarpments, and hadal realms where pressure rises to extremes even the abyss does not fully express. The life there will be different, not because it belongs to fantasy, but because every added kilometer changes the terms of existence. Before entering those depths, the submersible passes one more small scene on the bottom. A cluster of animals works over a piece of organic matter, perhaps the remains of something that sank from above. There is no drama in the human sense, no chase, no sudden violence, only the quiet transfer of energy from one form to another. It is the deep ocean in miniature: darkness, patience, hunger, adaptation, and the strange dignity of life continuing far from the sun. The lights move on, and the scene closes behind them, swallowed by black water that remains full, whether we see it or not. At the edge of the beam, a few animals rise from the sediment and settle again, disturbed by a presence that is bright, noisy, and temporary. The submersible is careful, but it is still an interruption. Its lamps create a false day that lasts only minutes. Its movement pushes water into places where water was nearly still. Its cameras turn private survival into human knowledge. This is the paradox of exploration. To understand the deep, we must enter it in some way, yet entering it always changes the moment we hope to witness. Scientists know this, which is why observation has become more patient, more precise, and more respectful over time. Remotely operated vehicles can hover, return, and record for long periods. Landers can sit quietly on the sea floor, waiting for animals to approach. Autonomous instruments can measure conditions without a human pilot looking out through glass. Each method opens a slightly different window, and none opens the whole ocean at once. The more carefully we look, the less the deep resembles a single dark room. It has seasons of its own, even if they are not felt as spring and summer in the way we know them. Changes at the surface can alter the amount of organic material that falls. Currents can carry oxygen, nutrients, larvae, and signals across enormous distances. Geological activity can create new habitats or shut old ones down. A whale fall may appear, flourish, and fade. A vent field may burn with life for a time, then weaken. A canyon may funnel food into deeper water. A seamount may gather animals around currents that pass its slopes. The deep is slow, but it is not frozen. Larvae of many deep-sea animals must also move through this vastness, sometimes drifting with currents before finding a suitable place to settle. This is another hidden drama, too small and dispersed for easy imagination.
How does a young animal find a vent, a seep, a coral, a carcass, or a stable patch of bottom in so much darkness? Researchers study chemical cues, current patterns, life cycles, and genetic connections to understand how populations persist across distances. The answers vary, and many remain incomplete, but the question itself reveals the scale of the challenge. Survival is not only about enduring pressure, it is also about arriving somewhere life can continue. For humans, that challenge has a strange mirror. We too are trying to find our way through the deep, but with maps, cables, ships, satellites, and machines. We drift intellectually where animals drift physically, following traces toward understanding. A chemical plume becomes a clue. A sound reflection becomes a possible feature. A sample becomes evidence. A brief video becomes a doorway into years of research. The ocean teaches humility, not by refusing knowledge, but by making knowledge difficult. It asks for patience before it gives shape to the unknown, and patience is exactly the mood
The deep seems to demand. Nothing here is rushed for our attention. The scavenger feeds because food has arrived, not because a camera is watching. The vent worm grows because chemistry allows it. The coral extends into a current because particles pass by. The fish waits because waiting works. The microbe transforms matter because that is its world. Human fear begins to soften when these patterns become visible. The abyss is not a haunted emptiness. It is a living system, severe and delicate, built from countless acts of adaptation. The bottom of the ocean is alive in ways that do not ask for human approval. It is alive as drifting snow, as scavengers, as glowing hunters, as soft, transparent bodies, as microbial films, as tube worms around heat, as corals on hidden mountains, as tracks in sediment, as chemistry becoming food. It is alive in patience and in sudden opportunity. It is alive in beauty that can look frightening, and in frightening forms that become beautiful once understood. Somewhere ahead, the map becomes less certain to the imagination, even when instruments remain calm. The descent will no longer be only a journey across the bottom, but into depressions cut deeper than most mountains are tall, places where the word depth begins to feel insufficient, and where human presence becomes even smaller against the weight of the sea. And now, as the seafloor falls away toward still greater depth, the journey moves toward the places where even the abyss seems to have an abyss of its own. The next darkness is lower, colder, narrower, and far more ancient. The slope drops away with the quiet certainty of a night road disappearing beyond the reach of headlights. The submersible does not fall, but the world beneath it seems to open. Sediment gives way to darker angles, to scarps and broken walls, to a geography shaped by plate tectonics, gravity, and time. Here, the bottom is no longer a broad plain receiving the slow rain from above. It becomes a threshold. The ocean floor bends into deeper places, into trenches carved where one piece of Earth's crust sinks beneath another, carrying rock, sediment, water, and the memory of ancient seas down into the planet. A trench is not simply a crack. It is part of a living Earth, if we can use the word living for geology, where plates move by centimeters each year and still reshape oceans over millions of years.
At subduction zones, dense oceanic crust descends beneath another plate, and along the surface of that descent, the seafloor can form long, narrow depressions. These trenches are among the deepest places on Earth. They are not common landscapes. They are the edges of vast tectonic machinery, quiet to the human ear during an ordinary visit, but powerful enough to build volcanic arcs, generate earthquakes, and recycle parts of the ocean floor into the interior of the planet. As the submersible approaches this deeper realm, the idea of depth changes again. The abyss was already beyond the human body. It was already cold, dark, pressurized, and remote, but the Hadal Zone, named after Hades, begins below roughly 6,000 meters in the deepest trenches of the ocean. It is a world within the deep sea, not spread widely across the planet like the abyssal plains, but concentrated in steep, isolated pockets. These places are difficult to reach, difficult to sample, and difficult to imagine. To descend toward them is to move from the hidden ocean into the hidden ocean's most extreme chambers. The pressure grows with every meter. At these depths, it is not a dramatic force that arrives suddenly, but a steady accumulation, the weight of the water column becoming almost beyond intuition. Human beings are not good at imagining pressure because we live inside a narrow band of it. We feel wind, weather, and altitude, but we do not feel the crushing presence of kilometers of seawater unless we enter a world where our bodies cannot follow. Engineers must design vehicles that can hold a human atmosphere against the outside ocean without failing. A small weakness, a flawed material, a bad calculation, a hidden fatigue in the structure can become catastrophic. The deep does not forgive carelessness, not because it is angry, but because physics is absolute. Yet even here, life appears. This may be the most important emotional and scientific lesson of the descent. The Hadal trenches are not empty cuts in the planet. They contain microbes, small crustaceans, worms, sea cucumbers,
Fish adapted to great depths, though different trenches host different communities. Some snailfish have been observed at extraordinary depths, their bodies soft, pale, and adapted to pressure in ways still studied carefully. Amphipods, shrimp-like scavengers, can appear in large numbers around bait placed by landers. Microbes work in sediments and on surfaces. The forms may not match the creatures of legend, but the fact of their presence is more astonishing than any legend needs to be. For a human watching from within a vehicle or through the recorded eye of a deep-sea lander, Hadal life can feel almost tender. It is not the monstrous kingdom that old fears might expect. It is often small, pale, precise, and quiet. A fish moves close to the bottom, shaped by cold and pressure. An amphipod approaches a piece of bait with quick movements that look almost ordinary, except that the scene is happening deeper than most mountains are high. A sea cucumber crosses sediment in darkness that no sunlight has ever touched. These animals live where the human mind expects only absence, and that makes them powerful in a different way. They prove that life does not always announce itself with size. Sometimes it announces itself by continuing. The trenches are isolated from each other by geography and depth. Each trench can function like a long, deep island system, connected to the rest of the ocean, but also shaped by its own history, chemistry, food supply, and physical conditions. Scientists study them with landers, remotely operated vehicles, submersibles, sediment cores, genetic tools, and careful comparisons among sites. Much remains uncertain, not because researchers have failed to ask,
but because access is so hard. A single dive or sample cannot explain an entire trench. A camera sees only the patch of world in front of it. A trap attracts certain animals and misses others. A sediment core preserves one narrow column of evidence. The hadal zone must be assembled slowly from fragments. This fragmented knowledge is not a weakness. It is part of the truth of deep exploration. At the surface, humans are used to broad maps and constant images. Satellites can watch weather systems move across continents. Ships can cross oceans in days. Aircraft can look down on mountain ranges, deserts, rivers, and cities. But in the deepest ocean, knowledge often arrives like a lantern in a cave. The light touches one wall, one animal, one plume of sediment, one instrument reading. The rest remains dark. The humility required here is not poetic decoration. It is scientific discipline. We must say what has been seen, what is likely, what is still unknown, and what remains beyond the present reach of evidence. The hadal world also asks us to think about time differently. Trenches are shaped over geological timescales by the movement of plates, but the animals within them live individual lives measured in days, years, or decades. Organic matter falls from above, sometimes funneled by the steep walls and local currents. Earthquakes can disturb slopes, move sediment, and reshape habitats. Landslides may carry material downward. The trench is not a dead bowl. It is a deep, dynamic environment where geology and biology meet under extreme pressure. The surface may never see the event, but the bottom records it in layers, scars, and shifts. Some trenches may receive more food than a flat abyssal plain because their shape can trap or funnel organic material. Others may be more limited. This variability matters because deep life is tied so strongly to energy. The old image of the deep as uniformly starved is too simple. There are gradients, pulses, and exceptions. A trench may collect falling matter in ways that create localized abundance. A slope may carry debris downward. A carcass may become a sudden feast. A baited lander may reveal scavengers capable of finding food quickly, even in extreme darkness. The deep is sparse in many places, but it is not passive. The submersible's lamps touch a wall of rock and sediment, and the ocean seems to become vertical again. The seafloor rises on one side like a dark cliff. Fine particles drift down from the disturbance of water against slope. The human eye follows the wall upward and loses it in blackness. In such a place, the fear of being underwater changes into the fear of being small inside geology. A whale, a squid, a fish, even a glowing predator belongs to biology, to bodies and hunger. A trench wall belongs
to planetary force. It does not move on human time, but it represents motion vast enough to open an ocean's deepest wounds. Human presence here is more limited than ever. A remotely operated vehicle may be connected by cable to a ship far above, its pilots watching screens, guiding arms, lights, and cameras through a delay of perception, not necessarily delay in signal so much as the distance between body and environment. An autonomous lander may descend alone, carrying cameras, bait, sensors, and weights, then release ballast and rise back to the surface with data. A crewed submersible may make the descent with people inside, but such dives are rare, expensive, and carefully planned. The hadal zone does not become familiar through repetition in the way a beach or forest can. It remains an expedition every time.
The psychological effect of this is profound. Humans are a storytelling species, and we often transform places into homes by returning to them, naming them, walking paths through them, building routines around them. The deepest ocean resists this domestication. We can name features, we can map them, we can measure them, but we cannot live there. We cannot stroll along the floor of the trench. We cannot feel the water on our faces and survive. We cannot make it ordinary. Even our most advanced visits remain brief acts of dependence on technology. The deep keeps its otherness, and yet the otherness is not emptiness. A small fish crosses the light, and its movement carries the entire argument of the journey. Life has entered the impossible and made it ordinary for itself. The animal does not know it lives in a place humans call extreme. Extreme is a human word based on human limits. For the fish, the water is simply the world. Its cells, membranes, enzymes, and internal chemistry operate within pressures that would disable organisms from shallower environments. Researchers continue to study the molecular adaptations that allow such life to function, including changes in proteins, membranes, and protective molecules. The details are complex, and different organisms solve pressure in different ways, but the broad lesson is elegant. Life does not defeat the environment by ignoring it. It becomes shaped to it. This idea returns us to every creature seen on the way down. The lanternfish did not overcome darkness by wishing for sunlight. It evolved light and camouflage. The anglerfish did not overcome scarcity by chasing endlessly. It turned attraction into a hunting method. The sea cucumber did not reject the muddy plain. It made a life from processing it. The tube worm did not need a green field. It entered partnership with microbes around chemistry. The hadelfish does not fight the pressure like a human machine must. Its body is built in relation to pressure. Again and again, the deep ocean shows that survival is not domination. It is fit, adjustment, intimacy with conditions. For humans, this is almost difficult to accept because our history is full of insulation. We make clothes against cold, walls against weather, lights against night, engines against distance, ships against water, aircraft against gravity, medicine against disease, and machines against pressure. Much of human success comes from building portable environments, little zones of survivable conditions that allow us to move through places not made for us. A submersible is one of the clearest examples. A pocket of surface atmosphere lowered into a world of crushing water. It is a triumph of engineering, but also a confession. We can visit the deep only by carrying a fragment of home with us. The trench reminds us of the limits of that strategy. Technology extends the body, but it does not erase vulnerability. Inside the craft, the air is warm and breathable. Outside, a quiet pressure surrounds everything. The difference between those two realities is measured in centimeters of material. The thought is enough to make the voice lower, the breathing slow, the mind settle into careful attention. There is no need for panic. Panic would be useless here. Calm is not only the mood of the documentary, it is the proper posture of survival. In the deep, every movement becomes deliberate. Every system matters. Every observation is earned. The lights drift across another patch of sediment. Small amphipods move quickly, their pale bodies appearing and vanishing near the bottom. Such scavengers are often among the most visible animals in Hadal observations.
Because bait attracts them. This creates an important scientific nuance. What cameras show near bait is not a full portrait of the community, but a portrait of animals drawn to a food source. To understand the deep honestly, researchers must account for the method of observation. A trap reveals who enters traps. A camera reveals what passes in front of it. A light changes the scene. A sample disturbs what it collects. Knowledge is always shaped by the way it is gathered. This does not make knowledge unreliable. It makes it careful. Over time, many methods overlap and patterns become clearer. Repeated observations, genetic analysis, environmental measurements, and comparisons across depths and regions build a stronger picture. Scientists learn which animals appear at which depths, how communities differ between trenches, how pressure and food supply affect life, and where the limits of certain groups may lie. The deep ocean remains mysterious, but mystery is not the same as ignorance. It is a landscape where knowledge grows slowly, like a faint light widening across the bottom. Far above, the surface continues without awareness of this exact moment. Waves pass, clouds move. Perhaps a ship holds position in the night, its lights small against the open sea. People on deck may feel wind and salt. They may hear engines, cables, voices, the ordinary sounds of an expedition. The distance between them and the submersible below is vertical, but it is also emotional. The ship belongs to the world of weather. The submersible belongs, temporarily, to the world of pressure. Between them lies a column of water filled with drifting particles, migrating animals, darkness, and time. This vertical separation is one of the ocean's great psychological forces. When we stand on land, the unknown often lies beyond the horizon. In the sea, it lies beneath the feet. A person can float above a trench deeper than Everest is tall above sea level and see only waves. The most extreme landscape on Earth can be hidden by a surface that looks calm enough to touch. This is why the bottom of the ocean has such power over imagination. It is not distant like another planet. It is concealed beneath something familiar. The hidden world begins exactly where the visible world ends. The question of what lives there now has many answers, but none of them are simple lists. At the bottom live animals that process sediment, scavengers that find rare meals, microbes that transform chemistry, fish adapted to darkness and pressure, worms that enter partnerships with bacteria, corals and sponges on hard slopes, communities around vents and seeps, and small pale creatures in the deepest trenches. But more deeply, what lives there is a different style of life. Life slower than ours, more economical, more dependent on faint arrivals of energy, more comfortable with darkness, more closely written into pressure and chemistry. The deep sea also contains records of what happens above. It receives organic carbon from surface ecosystems. It receives sediment from continents and the shells of microscopic organisms. It receives volcanic ash, dust, and the remains of animals. Increasingly, it receives traces of human presence. Plastic particles have been found in deep marine environments, and human-made debris has reached even remote seafloors. Pollutants can travel through water and food webs. The fact is not comforting, but it is important. The bottom of the ocean is not separate from the human age. It is far away in experience, but connected in material reality. This connection changes the meaning of exploration. To see the deep is not only to satisfy curiosity, it is to understand that our planet's hidden systems are still part of our responsibility. Deep-sea ecosystems can be vulnerable,
especially when organisms grow slowly, reproduce slowly, or depend on habitats that recover poorly after disturbance. Mining interest, deep fishing, pollution, climate change, and ocean warming or deoxygenation in broader marine systems all raise questions that science and society must approach carefully. The deep ocean is not empty space waiting for use. It is habitat, archive, chemistry, and life. At the same time, it should not be reduced only to fragility. It is also resilient in ways that come from deep time, from life adapting across enormous environmental range. Microbes have persisted through planetary change. Animals have colonized darkness, vents, carcasses, sediments, slopes,
and trenches. The deep ocean holds both vulnerability and endurance. That combination is more truthful than either comfort or alarm alone. It asks us to care without pretending we fully understand. It asks us to be cautious because we are still learning. It asks us to remember that the unseen is not the unimportant. The submersible turns slowly, and the lamps sweep across the trench floor. For a moment, the sediment brightens, and a small animal leaves a delicate track. Then the light moves on, and the track fades behind. Nothing dramatic happens, yet the scene feels complete. The deepest places on Earth do not need to reveal a giant creature to justify their wonder. A single track at hadal depth is enough. It says that life has crossed here. It says that a body moved through darkness under impossible pressure and left a mark. It says that the bottom is not a dead end, but a place where stories continue, too slowly and quietly for human senses to catch without help. As the journey begins to turn upward in feeling, even if the vehicle still moves near the bottom, the mind starts to gather what the descent has shown. The ocean is not a blue surface with a dark floor beneath it. It is a layered planet within the planet. Each depth changes light, pressure, temperature, food, senses, and strategy. At the top, sunlight feeds abundance. In the twilight, animals rise and fall in migrations larger than our eyes can follow. In the midnight, light becomes language and trap. On the abyssal plains, patience becomes a way of life. Around vents, chemistry becomes food. In trenches, pressure becomes a condition so complete that life must be built around it from the inside. The human story running through these layers is equally important. We entered with fear of creatures, but the deeper fear was always the environment itself. Not being able to breathe, not being able to see, not being able to trust our senses, not being able to survive without a shell. The deep sea strips away the illusion that humans are naturally suited to every part of Earth. We are powerful because we can understand and build, but our bodies remain specific. We are warm, air-breathing, light-loving mammals from the surface. The deep ocean receives us only when we arrive carefully, inside machines, for a little while. This realization can feel small at first, even humbling in a severe way, but there is comfort hidden inside it. To be small is not to be meaningless. The submersible is small, and yet it carries attention. The camera is small, and yet it opens a world. The human life inside the craft is brief compared with geology, fragile compared with pressure, and limited compared with the range of life. Yet it can wonder. It can ask what lives there. It can learn to answer without turning every unknown into a monster. It can look into darkness and come back with respect. Respect may be the deepest emotional result of the journey. Fear begins the descent,
Because fear is older than language, it watches for teeth, darkness, isolation, and the loss of air. Curiosity continues the descent because curiosity is one of the ways humans turn fear into knowledge. But respect is what remains when knowledge becomes wide enough. The anglerfish is not a nightmare. The whale fall is not only death. The vent is not magic. The trench is not emptiness. Each is part of a system that does not need to be simplified into comfort or terror. It can be strange and real at the same time. The lights turn upward now, and the submersible begins to rise from the trench floor. The bottom moves slowly away, first as visible sediment, then as pale texture, then as a suggestion beneath the beam. The animals remain. The microbes remain. The tracks remain until currents and sediment soften them. The pressure outside decreases almost imperceptibly with each meter, though it remains enormous for a long time. The vehicle carries its recordings, samples, measurements, and the quiet memory of a place where no human foot has touched the ground. As the craft rises, the darkness does not immediately change. The Hadal realm gives way to abyss, but the view outside is still black. This is another lesson in scale. Leaving the deepest place does not mean returning quickly to the familiar. There are kilometers of ocean above, each with its own conditions, each inhabited by lives adapted to water, pressure, hunger, and darkness. The journey back to the surface is not an escape from the deep, so much as a passage
through it in reverse. The same layers that felt like thresholds on the way down now feel like veils being lifted one by one. The first living lights appear again in the water column, a tiny flash, then another. The submersible passes drifting animals, perhaps a jellyfish folding itself through the dark, perhaps a small fish turning away from the lamps. Their presence feels different now. Earlier, bioluminescence seemed like mystery and warning. Now, it also feels like continuity. These creatures are not signs on a path made for us. They are lives crossing their own night. The human vehicle is the passing phenomenon, the temporary brightness, the strange object moving through a world that does not require it. Higher still, the deep scattering layer may be somewhere in motion, animals migrating according to rhythms tied to the sun far above. Even before daylight reaches the windows, the behavior of life knows the difference between day and night. This connection is delicate and beautiful. The surface sun does not shine into the abyss, but its influence travels through food webs, through migrations, through oxygen, through the falling matter that feeds the bottom. Nothing in the ocean is entirely isolated. Even the trench, remote and extreme, is linked to processes unfolding above it. For humans, this connection is perhaps the final scientific and emotional meaning of the journey. The bottom of the ocean is not a separate underworld. It is part of Earth's breathing system, carbon system, geological system, biological system. It is connected to climate, to plate tectonics, to the chemistry of seawater, to the productivity of plankton, to the death of whales, to the lives of microbes, and to choices made by a species that lives mostly on land. The deep is hidden, but not disconnected. Its darkness is not absence, it is participation without visibility. The submersible continues upward, and the mind can imagine the layers passing outside like pages closing softly. The trenches below hold their pressure. The abyssal plains stretch outward in cold darkness.
Vent fields continue to shimmer where chemistry rises. Whale falls continue their long transformation from body to habitat. Scavengers continue to search. Tube worms continue their partnership with microbes. Deep corals extend into currents. Tiny organisms drift in the water column. Lanternfish and other migrators prepare for the movements that repeat with the turning of the planet. None of this waits for human narration. The world goes on. That may be why the deep ocean is so well suited to a quiet kind of awe. It does not depend on us. It does not become meaningful only when seen. It was there before the camera, before the submersible, before science had names for its layers, before humans looked at the sea and imagined monsters beneath it. It will continue after the lights leave. The animals will not know that they have become part of a story. They will continue to follow chemical traces, drifting particles, pressure gradients, currents, and instincts shaped over generations. As the ascent reaches the midnight zone, the darkness begins to feel less absolute, though the change is subtle. The instruments know before the eyes do. The depth numbers fall. The pressure outside eases. The memory of the bottom remains vivid because nothing on the way up contradicts it. If anything, the vast water above makes it more impressive. The bottom is not just deep. It is deep beneath an entire living ocean. Layer after layer of animals, particles, currents, and chemical exchanges lie between the seafloor and air. To reach the bottom is to cross a vertical continent made of water. A faint blue eventually returns. Not daylight yet, but the idea of daylight. The black softens. Shapes become less severe. The human eye, deprived for so long, may feel relief before it admits relief. Blue is the color of return. It means that sunlight exists somewhere above, that the surface is real, that air is waiting. For the human body, this matters profoundly. No matter how advanced the craft, no matter how beautiful the deep, the body remembers where it belongs. It belongs to breath, warmth, gravity, and light. And yet, something has changed. The surface can never again be only a surface. After descending through the hidden ocean, a wave is no longer just water lifted by wind. It is the roof of a world. Beneath it are migrating animals, glowing signals, patient scavengers, microbial cities, ancient
sediments, chemical oases, mountains, trenches, and creatures that live their entire lives without seeing the sun. The calm face of the sea becomes more mysterious, not because it hides less, but because we know better what it hides. The submersible rises through the last blue water toward the ship. Above, a circle of brightness widens. The sea surface trembles like liquid glass. When the craft breaks through, sound changes. The world of pressure gives way to the world of air. Waves touch the hull. Voices return more clearly. The sky opens. Perhaps it is dawn, and the first light stretches across the water. Perhaps it is night, and the stars look down on the same ocean that has just revealed a darkness of its own. Either way, the return feels gentle, almost unreal. Inside the human mind, the journey continues downward even after the body has returned. The images remain: marine snow in the beam, a pale fish at impossible depth, an angler's lure glowing softly, a whale skeleton becoming a home, black smokers rising from the seafloor, tiny amphipods feeding in a trench, a track left in sediment where no sunlight falls.
These are not just curiosities. They are reminders that life is broader than comfort, broader than familiarity, broader than the environments that shaped us. What lives at the bottom of the ocean, then, is not one creature, one monster, or one simple answer. It is a web of lives adapted to darkness, pressure, scarcity, chemistry, and time. It is the patient continuation of biology under conditions that make humans feel fragile. It is a mirror held beneath the world, showing us that nature does not need to resemble us to be complete. The deep ocean is frightening because it removes us from the center. It is beautiful for the same reason. There is a kind of peace in that. The deep does not ask us to master it tonight. It does not ask us to solve every mystery before resting. It asks only to be recognized as real, immense, living, vulnerable, powerful, and mostly unseen. Somewhere below the waves, far beneath moonlight and weather, the bottom remains in darkness. Not empty darkness, but inhabited darkness. A darkness crossed by small bodies, faint lights, chemical warmth, drifting food, and the slow work of life. The surface settles. The ship drifts. The ocean breathes against the hull. Far below, beyond the reach of ordinary sight, the abyssal plains and trenches continue in silence. A sea cucumber moves across the sediment. A microbe transforms what has fallen. A pale fish turns in pressure that would crush the unprotected human body. A vent releases mineral-rich fluid into cold water. Marine snow keeps falling, softly, endlessly, like a message from the sunlit world to the dark. And still, even after all this, the bottom of the ocean is not finished with the human imagination. It remains unfinished because every expedition changes the edge of what is known. A camera records an animal at a depth where its kind was not expected. A sediment sample reveals microbial activity in a place once assumed too poor or too pressured for much life. A sonar map sharpens the outline of a slope, a canyon, a seamount, a trench wall. Knowledge grows in small pieces, and each piece does not close the mystery so much as make it more detailed. The unknown becomes more accurate, more textured, more worthy of care. This is different from the old mystery of sea monsters drawn on empty maps. Those monsters lived where knowledge had not yet arrived. The modern mystery is quieter and more demanding. It is made of real animals, real chemistry, real pressure, real uncertainty, and real limits in observation. It does not need exaggeration. The truth is already strange enough. There are fish with bodies tuned to crushing depths, animals that glow in patterns, communities living from chemical energy, microbes working below the mud, and entire habitats that may exist for years before any human eye sees them. The deep ocean has replaced fantasy with something more powerful, reality that feels almost impossible. This reality also changes the way we think about exploration itself. To explore is not only to go somewhere and return with images, it is to learn how to look without forcing the world into the shape of our expectations. Early human fear asked whether something down there might rise and take us. Science asks what conditions allow life to persist, how ecosystems connect, how energy moves, how species adapt, and how our actions reach
places we barely understand. The fear does not vanish. It becomes more disciplined. It becomes attention, Attention may be the most respectful form of wonder. It notices that a small amphipod matters, that a microbial film matters, that a slow-growing coral matters, that a sediment layer matters, that a place without sunlight can still have history. It allows the human mind to rest from needing everything to be large, fast, bright, or useful. The deep sea teaches value at another tempo. Some of its most important processes happen too slowly for a restless observer. Some of its most important organisms are too small for unaided eyes. Some of its most beautiful habitats are too remote to become familiar. Still, they matter. In this way, the bottom of the ocean becomes a lesson in hidden continuity. The world is not only what is visible from the shore. It is not only forests, mountains, deserts, cities, clouds, and stars. It is also the cold sediment under kilometers of water, the pressure held by ancient crust, the chemistry rising from vents, the soft fall of organic particles, the animals moving through darkness with no need for our names. The planet has depths in the literal sense, but also in the emotional sense. It contains more ways of being alive than a surface creature can easily imagine. Perhaps that is why returning from the deep feels less like ending a journey and more like carrying a quiet depth back into ordinary life. A glass of water, a rainy street, the sound of waves in a video, the taste of salt in the air near the coast. Each small sign can point downward. The ocean becomes layered in memory. Its surface remains beautiful, but it is no longer simple. Beneath every reflection is a distance. Beneath every distance is a habitat. Beneath every habitat is an older rule of the earth, patient and exact. And somewhere in that layered darkness, life continues beyond our fear of it. It does not wait for sunrise, because sunrise is not part of its world. It does not wait for human understanding, because understanding is our need, not its own. It follows pressure, hunger, chemistry, current, and time. It rises when instinct calls, settles when energy must be saved, feeds when chance appears, and disappears again into a darkness that is not empty, only unlit. That thought can be strangely comforting. The world is larger than our anxieties, deeper than our routines, and quieter than the noise we carry. Below the waves, life keeps its own slow rhythm in the dark water. And above it all, the night remains calm. The waves fold over the hidden depths. The stars appear small on the water. The human world grows quieter now, with its lights, its voices, its restless thoughts slowly receding. Beneath that quiet surface, the deep ocean continues without hurry, holding its creatures, its secrets, and its long blue-black silence. It is still there as your breathing slows, still there as the room fades, still there below every dark wave, alive in the cold, waiting for nothing, needing no witness, moving softly through the endless sleep of the sea.